All right, let's get started. So going over homework from last night, I know that there wasn't really a spot to turn it in. I just fixed that problem. So again, if you didn't get turned in last night, make sure you get it turned in. I extended the time also to tonight at midnight pretty much. So just make sure you get turned in, but let's go over this so that we can move on to the next section. Now, for the first set here, 1 through 6, you had to use one of two formulas. There are 3 formulas from yesterday. There is one for an angle on a circle. So angle on circle was always equal to half the intercepted arc. So arc divided by 2. Then you had an angle on the interior. So interior angle is equal to the first arc plus the second arc divided by 2. Then we had an exterior angle was equal to the big arc minus the little arc divided by 2. And I didn't even realize it, but that changed my. Hold on. There it is. So those were the 3 formulas from yesterday that that you had to use on those 12 problems. The top 6, there's only 2 of the formulas, the one that had the angle on the circle and the interior angles, those are the ones you're using. None of the top 6 were exterior. The bottom 6 were all exterior angles, so you're only using the bottom equation right this row. Going through these really quick. On number 1, we had 50 and 56. So if we add those 2 together, divide by 2, that gives us 106 divided by 2, which is 53. That's right. Then on number 2, same thing. 48 plus 38 divided by 2. 48 and 38, that gives us 86. Divided by 2 is 43. Is that our answer? No. 43 is this angle and this angle. Which angle do they want? They want angle 2. So we can use those lines, those chords are inside the circle. Any straight line has to be 180 degrees. So we have one more step here. 180 minus 43 leaves us with 137. That's that angle 2. On number 3. Now, we no longer have an angle in a circle. That one's the angle on the circle. That's the top equation there. We're taking the arc divided by 2. So we have 198 divided by 2. That's 99. On number 4, we have same idea, but wait a minute. The arc that's being intercepted isn't labeled. So we are given the other arc. We know that all the arcs in a circle should add up to what total? 360. So 360 minus the arc that we know leaves us with 236. So that's this arc. And now that we know that arc, we're going to divide that in half to get the angle. So 236 divided by 2 is 118. On number 5, we have the angle inside the circle again. So add them up. 6 plus 50 divided by 2. 106 divided by 2 is 53. Yeah, that's for these 2 angles. That's not our final answer. We have to subtract that from 180. 180 minus 53 is 127. Wait, did I do something wrong? Go back to, I could have done something wrong. I had 66, I had 50, added them up, got 106. Yep, I did something wrong. That's not 106. That should be 116, right? So let's see, 116 divided by 2, that should have been 58. So then this was 58 on both of those. If I subtract 58 from 180, that is now 122. Yeah, thank you. Which makes more sense because I think that's the answer about marriage years. I thought something was strange. Number 6, we got 228. That's again not the arc that's being intercepted, so you subtract that from 360 first. Subtract that from 360, we get 132. Divide that in half to get the angle measure, and you get 66. Yeah. That's all right. Any questions on those top 6?
Wait, how did you do the last one?
This one,
So.
first thing I did was 360 minus 228. That gave me the 132. Then I took the 132 and divided it in half. That gave me the 66. All right, moving on to the other side. I said other side, I meant the bottom. We can do the other side. All right. Now, I only told this class to do 1 to 10. My assignment from my other classes was up to 12. We didn't get to the one other example. It's a little more challenging here. So I'll do both 11, 12 with you as well. But going through the first few here, these are all exterior angles now. So this is that third equation I've written on the top. Exterior angle equals the big arc. I don't know why this is S. Minus the little arc divided by 2. Number 7, that gives the big arc and the little arc. So just plug it in. 120 minus 40 divided by 2. 120 minus 40 is 80. 80 divided by 2 is 40. That's our answer. Number 8, we're missing a piece, but all the angles still have to add up to 360. So 360 minus, we add all those up, we got, let's see, 2, 1, 3. We have 312 subtracted from 360 leaves us with 48. That's for this arc here. So now putting into our formula, 72 minus 48 over 2. That's going to be 24. 24 divided by 2 is 12. So 48. I have these 3 pieces given to me. All of them have to add up to 360. So I subtracted those 3 pieces. First, I added those 3. So I got 312. Subtracted it. 48 was the leftover piece. Yes. On number 9. Same thing here. We're missing a piece. So subtract from 360. The 2 pieces that we have. That's a total of 204. So we have 156 left over for this arc. Now that we know that arc, 156 minus 60 divided by 2. 156 minus 60 leaves us with 96. 96 divided by 2 is going to be 48. On number 10. Number 10 at first looks like there's not enough information, but there actually is. They gave us one little mark in there that they didn't give us on any of the other problems. What did they label or mark in figure 10 that was different than any other problem that we had on the figure? All right, how did you know it was a semicircle? All right, I think I heard it in that. So you're right to say semicircle. I just wanted to know what keyed you into it. They gave you a center point. None of the other problems have a center point drawn in. If they draw a point like that in the middle of the circle, it's safe to assume that that's the center point. That's the only reason why they would draw a point like that in a circle. So we have our center point, the line passes through the center point, which makes this separated into two semicircles. So on this side, we have 180 degrees. On this side, another 180. So if I subtract the 45 from 180, that leaves me with 135. Right? So now that I know my two pieces I need, plug it into my equation. 135 minus 45 divided by 2. That's 90 divided by 2, which is 45. 11 and 12. These are the two that I said were challenging. And in this calculator, I didn't get a chance to go over the example yesterday. They only give me an angle measure. They don't give me either of the arcs. They want me to solve for the arcs. Yes.
How do you get 130?
So you just told me it's a semicircle, right? Yes. So this side is 180. This side is 180. So I did 180 minus the 45. That's what gives me the 135.
Why did you do 135 minus 45?
This whole half is 180, right? This whole half is 180. So I just did that 45 subtracted from 180 to get that piece.
Then why did you subtract it again? You're talking about why did you say that if you already did 180 subtract that 45?
Oh, because this is my big arc. This is my little arc. Remember, when I'm doing my equation, I'm plugging in the two intercepted arcs. So the intercepted arcs here, big one and the small one, are those two. That's that equation. Big arc minus little arc.
Oh, okay.
Okay. So I had to find the big arc first, but then once I had the big arc, so I had to use the little arc to find the big arc, and then I had to use both of them to find the angle measure. All right, let's move on to the other two. So again, on these two, I am given the angle. I don't have either arc measure. Whatever one I want to solve for, I'm going to go ahead and label that as X. So in the first example here, we have DPA. It's a major arc. They use 3 points. I know it's asking me to find this one because they use those 3 points. So I'm going to label this arc as X. The other smaller arc there, I don't have a measure for that one either. But I do know that the entire circle is what? 360. So I can say that this little piece is represented as 360 minus X. So now I can plug into my equation. We have 84, goes in for my exterior angle. We have the big arc, which in this case was X, minus the little arc is 360 minus X over 2. And now we're going to solve. Well, first step in solving this one, I have 2 on the bottom. I'm going to multiply it out of my denominator to the other side. We get 168. On the top, I have a negative in front of that parenthesis. What's going to happen with that negative sign? Well, I have to take it and distribute it to both of those values in the parentheses. So this becomes negative 360 and a positive X. And I can change that to a plus sign once I distribute it. So I have a positive X, that gives me 2X. I have a negative 360. Again, I had it minus here, right? That's my formula. And then I distributed that to both of these parts. Because I had it written as an expression, I had distributed it to both pieces. So now, once I did that, I combined my like terms. I had X and an X, gave me 2X. I have negative 360, so I've simplified it. Bring that 360 across the other side by adding it, that gives me 528. And finally, divided by 2, and we get 264 for x. 264 is going to be my answer, so I made x the one I solved for. Number 12, very similar, but instead of solving for the big arc, they're asking me for LJ. Anytime I only have 2 given to me, it has to be the minor arc. So it has to be this piece. So now in this one, I'm solving for this piece. We'll call that one x. Next, then the other side will be 60 minus x. So now, plugging into my equation, I have 34, my angle, equal to, the big arc this time is 360 minus x. The little arc is x, so minus x, divided by 2. Again, I have my equation, I'm going to solve. Multiply 2 out to the other side, it gives me 68. Here, I don't have to distribute anything this time. I don't have a negative for the parentheses. In fact, the way this is written, do I need parentheses? No. So I can go ahead and just combine my like term. I have negative x and negative x. So I have 360 minus 2x. Bringing 360 over to the other side by subtracting. That gives me 292. Now, both of these are still negative at this point. So negative 292 and negative 2x. Divide off the negative 2, and we're left with 1. So again, those two are kind of challenging because they didn't give us either of the arcs. But again, since we know a circle is 360 degrees, we're able to use one variable to write an expression for both arcs. All right. Any questions? All right. Did I give you a new paper yet? No, right? I'm going to pass out 2 things real fast. My right sheet here. Oh, you haven't got signed out yet?
No, I'm getting signed out. Right at the end, like 3 minutes after mine was like.
Okay, we do have one other thing that I want to pass out to you. Yeah. And then let me put this up on the board. So tomorrow, or not tomorrow, next week, we have Wednesday. It's kind of a crazy day. It's an SAT day. Now, next Wednesday is SAT day. So we have SAT for all 11th graders and then some 12th graders. All right. So again, your teacher already told you if you are going to be on that one for a 12th grader, but for reading and writing group camps, that's going to be for all 9th and 10th graders. So 11th graders and some 12th graders will take the SAT. 9th and 10th graders will be doing reading boot camps for the time that they're tested, which the test is about 4 hours.
No.
Okay.
Wait, when? Today?
Next week. Next week.
Now, on here, so what they have given us though, they had them up in the office, they had posted something on the website. These last 3 periods of the day, because after we eat and stuff, then we have 3 classes, first, third, and fourth. It doesn't make a whole lot of sense as to why they chose those 3 periods, but that's what they chose, first, third, and fourth. So we will have those 3 periods at the end of the day on Wednesday, for about 30 minutes each. Doesn't make a whole lot of sense, but they also had these forms in the office and online. I printed them off for you. If you want to get signed out that day and you want to get signed out ahead of time, that's what this form is for. All right, getting your sign out approved ahead of time. So if you want to get signed out early after the SAT day or after the boot camps, and you have a way to get home, then this is what you need to get turned in, and it needs to be turned in by tomorrow. All right. Yes, again, the parents supposed to sign on this, but well, they had them in the office the last 2 days, but I decided to print them off so that more people. Oh, you don't need one?
Mister, I have a question though.
What's your question?
Do we have to come to the book camp? Okay, my sheet is not, it's the back of my sheet. I don't know what it is, so you gotta tell me.
I mean, it's just to help at the same time. I'm not gonna say. So it's coming tomorrow. And then on the day of testing, they're gonna give a copy to homeroom teachers. So that you'll have, we'll give out the copy. It's just kind of like that other, like, what was that? If you had it signed ahead of time, had a copy that they gave back, and then you showed it, so you know. I should have. I can get up. Okay, we good? Did I miss anybody? So, okay, if you lose that, I'll add it on Canvas tonight. I haven't had a chance to do that yet, but that's next Wednesday. Next Wednesday. All right, but again, the paper is due back tomorrow by noon, it says. So make sure you drop it off in student affairs if you want to get signed out early that day. That way, getting off campus, then Tuesday and Thursday. All right, let's move on. Come back over to this. Okay, so the other thing that we're doing today. Okay, on here, there are a couple more properties. There's 3 more equations. Yesterday we talked about angles and arcs. Today we're talking about the length of segments. So on here, this first half of that sheet is talking about 2 chords intersecting inside a circle. If you have 2 chords intersecting inside a circle, then there's a special property for the lengths of the parts of those chords. So if you take the 2 parts of the one chord and multiply them together, it should equal the 2 parts of the other chord multiplied together. So the product of the parts of one chord is equal to the product of the parts of the other chord. Now, on here they labeled them as A, B on the same chord and C, D on the same chord. So they said that A times B equals C times D. And the example they gave, we have 3 and 8 on the same chord, so we did 3 times 8. 6 and X are on the same chord, so 6 times X. 3 times 8 is 24. So 24 is equal to 6X. Divide by 6, X is 4. That's it. Alright, I'm gonna run through some of these examples. It's like the same thing every single time. You set it up, you solve, and there's not usually a whole lot of steps. There are some problems on here that can get kind of challenging. I am not going to give you problems that require a lot of solving quadratics. Alright, could you get a problem on the FSA at the end of the year for geometry, EOC on solving a quadratic? Yes. How many problems will you have to actually solve using a quadratic?
A lot.
For geometry, maybe like one. Alright, maybe two at most. So again, the algebra FSA, that one, there's a lot of solving quadratics, but the geometry one, not a whole lot. Alright, there's like two or three sections where you could have quadratics. This is one of them. So let's do some examples. I am not going to test you on solving quadratics, by the way. I'm not going to give you any assignment problems on solving quadratics. So first, looking at number one. Yeah, what two parts are on the same chords? So number one, we have the 2 and the x on the same side, on the same chord. So put those together. The 3 and the 6 are on the other chord. So we put those together. 3 times 6. 2 times x is 2x. 3 times 6 is 18. Solve by dividing by 2. That's it. That's our answer. On number 3, I'm just going down this side first.
Wait, what?
Huh? Yeah, I know. I just did work so fast. It's like, what happened? There wasn't a whole lot to it. 2 times x, 3 times 6. Set them equal. Divide by 2. You got an answer. The next one, same thing. All right. 6 and x are on the same line. So I'm multiplying 6 times x. On the other side, I have 8 and 8. I'll try. It's hard to do this one slow. All right, so we have the 2 parts on the same line, 6 and x. The 2 parts on the other chord, 8 and 8. Multiplying them together, so 6x equals 64. Divide by 6. 167. Well, sorry, I said 167. 16.7. Sorry, I always do math in my head. Sometimes it doesn't come out right when I'm talking and right. But 16.7. Yeah. Yeah, because you have, if you were to do this, right? 6 divided by 6 is 1. Right? Did I? Oh. Nope. Yep. 10.7. 0. Where did I get 36 from? I don't know. See, look, I was doing my head. I told you. Sometimes it comes out wrong. You guys gotta double check my work. 10.7. Thank you. See, if you can use a calculator, it does help.
Wait, what happened?
I did it wrong in my head.
Oh.
So yeah, it happens sometimes.
See, at least you can do it in your.
Oh, apparently I can't, but most of the time I can. All right, next one. We have, this one is actually really easy. You don't even have to use the property that was on this paper. What's special about it?
Could you just set them like?
Yeah, these are all radii because they put in a center point. So 5 is equal to x plus 2, right? Subtract 2, and x is 3. That's it. If they put them in, if they're both giving radii like that, yes. They do show other ones where like this one's going through. You can't do it on that one because they're both not. So yeah, you still have to use the property. All right, on 7. All right, this one, a few more x's, but that's okay. We got 6 times 5, and we got 2x times 3x. 6 times 5 is,
Wait, what?
30.
Wait, can you
I just went down this side of the paper, sir. It's not on the side of the board. I'm gonna go over there in a second. I just did feel like being there, what today, going back and forth. All right, so 2x times 3x. Close. 6x is almost right. You're missing one little piece.
What?
squared. Because when we multiply this, there's 4 values there. There's a 2, an x, a 3, and an x. It's all being multiplied. So the 2 and the 3 multiplied to give us 6. X and x gives us x squared. All right, we weren't adding, we were multiplying. Currently, this is 2 times x times 3 times x. So you have to treat those individually. That's math. Same rules always apply. All right, so bring the 6 over, divide it. No, not divide it, you have to get rid of the square. Square root is the opposite of square. And this one, again, said round, so this is 2 point, I don't know, I want to say 2.2, but somebody tell me I'm wrong.
Good, somebody tell me it's wrong.
2.2, 2.3,
You're wrong.
you're right. I'm right, 2.2, all right.
Damn it.
All right, number 2, this one, we have 2 x values. Again, that's okay. This is, for number 2, we got x times x. We have 2 and 10. X times x is,
X squared.
2 times 10 is 20. And again, we can take the square root of both sides to get x by itself.
4.
If we wanted to, we could actually get this all the way down to a simplified radical. They told us to round, however, so
4.
the rounded answer was 4.5, right?
What?
Yeah, 4.4, but this is actually.
Wait, well, what?
Why would we have? That's what the square root of 20 is.
Oh. You put the 2, I thought it was.
20 is not a perfect square. 16 is 4 times 4. All right, we good? All right, next. So we're gonna go look at one challenging one. Again, I am not putting anything like this on the test. This is my last example on this part of the paper. This one is gonna give us a quadratic.
Which one?
Number 4.
Oh, no.
So we have 3 times 6, right? On the other side, we have x times x plus 7. If we multiply those 2 pieces, we're gonna have to distribute. So we get 18 over here, and this becomes x squared plus 7x. And since we have an x squared and we have a separate 7x, we're now talking about solving quadratics. And there are 4 different ways that you could solve a quadratic back in Algebra 1, whether it was factoring, graphing, completing the square, or using a quadratic formula.
What's that?
All those work, right? Now, do I feel like we need to go over all those for this school year? No. Again, like I said, on the geometry FSA, you're only gonna have maybe one, possibly a second question that uses quadratics. Not a whole lot, not worth it, because what you can do on the FSA, a lot of times, not every question is multiple choice, but there are a lot of multiple choice questions. So a lot of times you can narrow it down. There's a good chance the quadratic one might come out as a multiple choice answer, and you could just end up plugging in. So is it worth me going over for 2 questions that may even be multiple choice? No, because then you could simplify it to a certain point, try plugging in values, and see if you get the right answer. There's a good chance that's how it's gonna be, so. I'm not going over all of them, however, I'm gonna do one example here today. So, solving this quadratic, I'm gonna go factoring method on this one, get the 18 over to the other side, so that we're saying it's equal to 0.
Oh, wait, what?
Yeah. Oh, that's nicer. All right. If you're solving by factoring, this one has a lead coefficient of 1. So we could look at that last term, the C value, find factors of C that add to give you B.
Wait, how do?
So again, I'm not going over all the steps of factoring right now. I'm just showing one example. All right. So factors of 18 that add to 7. Again, that's a negative 18. So that's going to be a 9 and a 2, with the 2 being a negative. So we're going to have x plus 9 and x minus 2 that we factored this. Since we now have two factors that are being multiplied and equal 0, I'm gonna set each factor equal to 0 and solve. So x plus 9 equals 0, and x minus 2 equals 0. So x equals -9, or x equals +2. This is a blank on there, so I couldn't have a negative value. So this one doesn't work as a solution. The only solution would be the +2. Don't really have to worry about that. You won't see any quadrats on the next test or anything. Now, when you get back to algebra 2 next year, you're gonna have to do factoring again. All right, so it'll come back to you. But yeah. Any other questions here? Let's move on to the other page then. So, with that, hey, did I just do that whole thing?
Wait, can you do number 6?
I just realized I put that on the overlay, and that did not save correctly. Did it? All right, well, that's rough, but. What was the question?
Can you do number 6?
Number 6.
It's kind of like number 5, but.
Number 6 is a lot like number 2, actually. Because if this is x, this one's also x. You know, one of our properties from a couple sections ago, we have a right angle, so this piece is being bisected. So both of those are x, so we have x times x equals 2 times 7. X squared equals 14. Sides. X is the square root of 14, which is 3.8, I want to say. Maybe 3.9. What is it? 3.7? What comes after the 7? Again, you think about perfect squares. 16 is a perfect square, so that would be, yeah. Again, have to be less than 4. Because it's less than 16. All right,
And then I have a question.
yes,
For number 8, would it be 3x times 8? And then
it'd be
6 times
3x times x is equal to 8 times 6. Alright, so I kind of screwed that up. Oh well. Let's move on to the next one. Oh, now I do have that going in the background too. I've got all sorts of stuff going here. Clear. Next. All right. So on this one, we're going to have. Oh, I know. Exterior and the hole. Exterior and the hole. So the equation here, when the intersection is outside, is going to be exterior times the hole of one is equal to the exterior times the hole of the other. Same thing really applies over here as well, but you have a tangent instead of a secant. So this tangent piece can go in for both the exterior and the hole. So if I'm doing tangent times tangent, that's actually going to be tangent squared. So tangent squared equals exterior times the hole of the secant. Yeah, really the same equation, it's just the exterior and the hole piece is the same.
There's no difference between those two.
So this is from one side, this is from the other side. That's it. Now, I know we're gonna have time to do an example here. I want you to try a couple. I'm not assigning the whole page. What I want you to do for homework is page 45. And I'm only giving you 1 through 3 and 8 and 9. All right, so just those 5 problems you try. So 8 and 9 is using this equation. So, but it really is plugging in and then solve. So I want you to try them. We'll go over them tomorrow. We'll do more practice with this on Friday because I'm gonna We're gonna go back over all the formulas that we've done this week on a worksheet tomorrow, so that we have them all in one place to study. Any other questions? No? Alright.